Welcome to a deep dive, into the world of Mendelevium.
Mm-hmm.
Now, this isn't an element you're going to, stumble upon, in your backyard.
No.
Mendelevium is a synthetic radioactive element,
Right.
meaning it's completely made by us humans.
Yeah. And what makes Mendelevium truly fascinating is that it represents sort of a turning point in how we create elements.
Oh,
It's the first one where the usual go-to method, bombarding an element with neutrons, just wouldn't work.
oh, wow. So it's like we hit a wall in the periodic table.
In a way, yes.
Wow.
Yeah.
We have some great source material for today's deep dives.
Yes.
And I'm really curious about how they actually discovered it,
Right.
given those limitations.
Yeah.
So what do we know about Mendelevium and why is it so important,
Yeah.
even though we can only create, minuscule amounts of it?
Well, Mendelevium gives us a glimpse into the extremes of matter.
Okay.
And studying it can reveal so much about nuclear physics and chemistry.
Mhm.
It's a bit like exploring a new continent. You never know what you might find.
I love that analogy.
Yeah.
Let's rewind the clock back to 1955, UC Berkeley.
Okay.
Our source material talks about the incredible scientific detective work
Yeah.
that went into discovering Mendelevium.
Right.
The researchers at Berkeley were already pioneers
Mm-hmm.
in synthesizing transuranic elements,
Yes.
elements heavier than uranium.
Exactly.
But with Mendelevium, they encountered a unique obstacle.
They did.
The traditional method of neutron bombardment, which had worked so well for previous elements,
Yeah.
ran into a problem with fermium,
Right.
specifically its most stable isotope, fermium-258.
Exactly.
What was the issue with fermium-258? Did it have something to do with its half-life?
Exactly. Fermium-258 has an incredibly short half-life
Okay.
and undergoes spontaneous fission before it can capture another neutron.
Uh-huh.
Essentially, it breaks apart before it can become anything heavier.
Oh, I see.
Yeah.
So how did they overcome that? They couldn't
Right.
just keep adding neutrons.
No, they had to invent a whole new technique, a brilliant method that actually earned them a Nobel Prize,
Wow.
the Recoil technique.
Okay. I am definitely intrigued.
Yeah.
How did this recoil technique actually work? Did it have something to do with alpha particles?
They bombarded a target made of Einsteinium with alpha particles, which
Okay.
are essentially helium nuclei.
Uh-huh.
And this collision was powerful enough to cause some of the Einsteinium atoms to fuse with the alpha particles, creating Mendelevium.
Wow.
The impact literally kicked the new Mendelevium atoms away from the target where they were caught on a special foil.
Oh, so instead of adding to the target element, they created a new element entirely.
Yes.
Okay.
And the process required incredible speed and precision.
Oh, yeah.
Because those Mendelevium atoms were highly unstable and decayed rapidly.
It's mind-blowing that they were able to synthesize Mendelevium.
Yeah.
One atom at a time.
One atom at a time.
Our sources mentioned it took three-hour sessions
Yeah.
just to produce a few atoms.
It's remarkable.
It makes you appreciate the dedication and ingenuity of these scientists.
Absolutely. The dedication was remarkable.
Yeah.
And speaking of remarkable, the story of how it got its name is also quite fascinating,
Oh,
especially considering the political climate at the time,
right.
the height of the Cold War.
Right. Naming it after Dmitry Mendeleev,
Yeah.
the Russian chemist who created the periodic table,
Mm-hmm.
must have been a bold move.
It was definitely a significant gesture.
Yeah.
There were diplomatic considerations and negotiations, but ultimately the scientific community acknowledged Mendeleev's massive contribution to chemistry,
Yeah.
and the name stuck.
It really speaks to the unifying power of science
It does.
that transcends political boundaries.
Absolutely.
And let's not forget the fun fact about its symbol.
Oh, yes. It was originally Mendeleev, but was later changed to Mdal
Okay.
to avoid confusion with other elements.
So we've talked about the discovery and the naming,
Right.
but what do we actually know about Mendelevium itself?
Right. What do we know?
What would it look like if we could see it?
That's where things get a bit tricky.
Okay.
We've never actually been able to produce enough Mendelevium to see it with the naked eye.
Oh, wow.
We're talking about working with individual atoms,
Okay.
not grams or kilograms.
So no one has ever held a piece of Mendelevium in their hand?
Not yet.
Not yet.
But that doesn't mean we're completely in the dark.
Okay.
Based on our understanding of the periodic table and the properties of its neighboring elements, scientists can make pretty accurate predictions
Mhm.
about its appearance and behavior.
Okay, so what are those predictions?
Right.
What do they think it would look like?
Scientists believe it would be a solid metal at room temperature,
Okay.
likely with a silvery white or grayish color,
Uh-huh.
similar to other actinide metals.
Okay.
They also estimate a melting point around 800 degrees Celsius
Wow.
and a density about 10 times that of water.
Wow. So if we could hold it, it would be incredibly dense.
Yeah, very dense.
It makes you wonder why it's so difficult to create in larger quantities.
Right?
Is it just the limitations of our technology, or is there something inherent about Mendelevium itself?
It's a bit of both.
Okay.
The technology for creating these super heavy elements is constantly evolving,
Mm.
but Mendelevium itself poses some unique challenges due to the behavior of its electrons.
Okay, now we're getting into the territory I love to explore.
Okay.
Tell me more about these electrons.
Well, as we move further down the periodic table into the realm of heavier elements like Mendelevium,
Mm-hmm.
the electrons start to behave a bit differently.
Okay.
They experience what's called relativistic stabilization.
Relativistic stabilization.
Yeah.
That sounds intense.
It is.
Okay.
Essentially because the electrons in heavier atoms are moving so incredibly fast,
Mm-hmm.
their mass actually increases.
Oh.
And this affects how they interact with the atom's nucleus.
So it's not just about the number of protons and neutrons in the nucleus.
Right.
But also how the electrons are behaving.
Exactly.
Right.
And in the case of Mendelevium, this relativistic effect leads to it preferring a +2 oxidation state.
Yeah.
This basically means it has 2 electrons available for bonding.
Mm-hmm.
This preference for a +2 oxidation state has a profound impact on its chemical properties and makes it much more difficult to isolate and study in larger amounts.
So it's not just about having the right equipment.
Right.
Mendelevium's own nature makes it incredibly elusive.
It does.
We know it's dense
Yeah.
and likely silvery white or gray.
Mm-hmm.
But what about its chemical behavior?
Right.
Does it react with other elements?
Well, most of our understanding of Mendelevium's chemistry comes from studying it in solution,
Okay.
where its reactions are more nuanced than, say, an explosive reaction with water.
Okay.
Mendelevium typically carries a positive charge, often +3,
Mm-hmm.
but it can also shift to a +2 or even +1 charge depending on the conditions.
So it have multiple personalities,
You could say that.
chemically speaking?
Yeah.
Well,
Understanding these different oxidation states is crucial for figuring out how to work with and study Mendelevium.
it seems like we're dealing with an incredibly complex element,
Yes.
especially since, as you said, we're working at the atomic level.
Right.
Let's talk more about that.
Okay.
What does the structure of a Mendelevium atom look like?
Mendelevium has a whopping 101 electrons orbiting its nucleus.
101 electrons.
And the way these electrons are arranged,
Wow.
their configuration plays a huge role in its chemical behavior.
101 electrons.
Huh.
I vaguely remember electron configurations
Yeah.
from high school chemistry,
Sure.
but it's all a bit fuzzy now.
Well, the basic idea is that electrons in an atom are organized in specific energy levels or orbitals,
Uh-huh.
and it's the outermost electrons, called valence electrons,
Okay.
that are involved in chemical bonding with other atoms.
So the way those 101 electrons are arranged
Yes.
is what makes Mendelevium behave differently from other elements.
Precisely, its electron configuration makes it quite distinct from the earlier elements in the periodic table.
This is all so fascinating.
Yeah.
But speaking of differences, I read that Mendelevium comes in different varieties
It does.
called isotopes.
You're right. Isotopes are like variations of an element.
Okay.
They have the same number of protons, which defines the element, but a different number of neutrons in their nucleus.
Ah, okay. So it's like they have the same face but different outfits.
A good way to think about it.
I like that.
Mendelevium has 17 known isotopes,
Wow.
but they're all radioactive and most decay very quickly.
So they don't stick around for very long.
Not at all.
Okay.
The most stable isotope, Mendelevium-258, has a half-life of 51 days.
Okay.
But the isotope most often used in experiments, Mendelevium-256,
Uh-huh.
only lasts for a little over an hour.
Wow, imagine trying to study something that's constantly disappearing.
I know, it's a challenge.
No wonder they need those incredible techniques we talked about.
Right.
Speaking of which, how do they actually produce and isolate Mendelevium?
Right.
It's not something you can just whip up in a lab, right?
You're absolutely right. It's not a simple process.
Okay.
To create Mendelevium, scientists use these massive machines called particle accelerators.
Mm-hmm.
They accelerate ions to incredible speeds and then smash them into targets made of heavier elements.
I imagine it's like trying to hit a bullseye, but on an atomic scale.
That's a good analogy.
Yeah.
And just like in archery, the type of arrow you use matters
Right.
depending on which isotope of mendelevium they're aiming to create.
Uh-huh.
Scientists use different combinations of target materials and ions.
Okay.
For instance, they might use bismuth, plutonium, americium, or even einsteinium as targets,
Okay.
bombarding them with ions like argon, carbon, nitrogen, or those alpha particles we talked about earlier.
So it's almost like a recipe book for creating new elements
Precisely.
with different ingredients leading to different results.
Exactly.
But the challenge is that even with the most advanced techniques,
Right.
the amount of mendelevium produced is unbelievably tiny.
It is.
We're talking femtograms,
Femtograms.
which is a quadrillionth of a gram.
Yeah, that's right. A quadrillionth of a gram.
That's mind-bogglingly small.
It is incredibly small.
How do they even begin to work with such minuscule quantities?
It requires a combination of ingenuity and cutting-edge technology.
Okay.
Once the Mendelevium atoms are created, they have to be isolated from the target material and all the other byproducts of the reaction.
That sounds like an incredibly delicate process.
It is.
Is that where the recoil technique comes into play again?
Remember how the Mendelevium atom gets kicked back during the collision?
Right.
Scientists can actually calculate its trajectory and position a special foil in its path to catch it.
Wow.
It's a bit like setting a trap for a very specific, very tiny particle.
So it's not just a random collision.
Yeah.
They're directing those atoms to a specific location.
Yes, very precise.
What happens next?
Well, this catcher foil is placed inside a chamber filled with helium gas.
Uh-huh.
A jet of this gas gently carries the Mendelevium atoms, transporting them to a different section of the apparatus for separation and study.
It's amazing how they've managed to control and manipulate these atoms.
Yeah, it's quite remarkable.
On such a minute scale.
Yeah,
It seems like every step requires incredible precision.
it does. Every step is crucial.
But the journey doesn't end there.
No, it doesn't.
To purify the mendelevium, scientists employ a technique called chromatography.
Right, chromatography, a very useful technique.
Chromatography, I remember doing that in high school chemistry.
Oh, yeah.
We used it to separate colors in ink.
The principle is similar.
Okay.
They pass the mixture through a column filled with a special material.
Uh-huh.
Different elements stick to the material with different strengths,
Okay.
which allows scientists to wash them out one by one.
So they're essentially sorting the elements
Yes,
based on their chemical properties.
exactly.
And then comes the crucial step of elution.
Right.
That's where they use specific solvents to wash the mendelevium out of the column
Yes,
at precisely the right time,
precisely.
isolating it from any remaining impurities.
It's a very delicate dance.
It sounds like a high-stakes chemistry puzzle,
It is.
where each step is meticulously planned and executed.
You could say that it takes incredible precision and a deep understanding of Mendelevium's chemical behavior to successfully isolate those precious few atoms.
It makes you wonder, with all this talk about radioactive elements and these intricate procedures, how do they ensure the safety of the scientists involved?
That's a very important consideration. Safety is absolutely paramount when dealing with radioactive materials like Mendelevium.
I can imagine. Are there specific guidelines they follow?
Absolutely. Organizations like the International Commission on Radiological Protection set strict limits for exposure to radioactive elements.
Okay.
For instance, for Mendelevium-258, the amount considered safe for ingestion is incredibly small, about 2.48 nanograms, which is less than a billionth of a grain of sand.
Wow.
And the inhalation limit is even smaller, around 16.5 picograms.
Those are incredibly tiny amounts.
They are.
It really highlights the potency of radioactive materials, even in such minuscule quantities.
Exactly. While Mendelevium holds immense scientific value, its radioactive nature demands the utmost respect and caution.
For sure. It reminds us that pushing the boundaries of scientific exploration often involves working with materials that require the highest level of care and precision.
That's a very important point. Scientists are constantly developing new techniques and protocols to ensure the safe handling and study of these incredible yet potentially dangerous elements.
So we've explored the challenges of creating, isolating, and even just defining what mendelevium is.
We have. It's been quite a journey.
But what I'm really curious about is what's the point?
Right.
Why go through all this trouble for an element that exists in such small quantities and decays so rapidly?
That's a question that goes to the very heart of scientific inquiry.
Okay.
While Mendelevium might not have immediate practical applications right now, it provides us with invaluable insights into the fundamental nature of matter.
Yeah.
It's like peering into a world where the rules of chemistry and physics as we know them are being stretched and challenged.
Could you elaborate on that?
Sure.
What kind of rules are we talking about?
For example, the way Mendelevium's electrons behave with that relativistic stabilization we discussed
Right.
forces us to reevaluate some long-held assumptions about how heavy elements interact.
I see.
It's a reminder that there's still so much we don't know about the universe, even at the atomic level.
So Mendelevium is essentially pushing the boundaries of our scientific understanding.
Absolutely. By studying Mendelevium, we gain valuable insights into nuclear structure,
Yes.
radioactive decay, and even the limits of the periodic table itself.
Uh-huh.
It's like exploring uncharted territory in the world of chemistry.
It sounds like Mendelevium, though, incredibly rare and fleeting,
Yes.
is playing a key role in helping us to rewrite the textbooks of chemistry and physics.
Exactly. It challenges us to think differently and to question what we think we know about the building blocks of the universe.
It's like we're piecing together a giant jigsaw puzzle.
Yeah.
And Mendelevium represents one of those unusual, almost impossible to find pieces. That, once slotted in, changes our entire perception of the picture.
I love that analogy.
Me too.
And who knows, maybe one day this knowledge will lead to practical applications we can't even imagine yet.
It's amazing to think that something so elusive could hold such potential. This deep dive has definitely been a journey into the extraordinary.
It really does make you appreciate the power of basic research, right?
It does.
We might not see immediate practical uses for something like Mendelevium, but
Right.
the knowledge gained from studying it could have ripple effects throughout science.
Absolutely. And it's not just about potential future applications, is it?
No.
Studying Mendelevium also helps us to understand the limits of what's possible in the universe.
Exactly. Mendelevium is pushing the boundaries of the periodic table as we know it.
Right.
It challenges our understanding of nuclear stability, the forces that hold atoms together, and even the fundamental nature of elements themselves.
It really makes you wonder what other secrets are hiding at the edges of the periodic table. What other elements might be out there waiting to be discovered?
It's an exciting thought, isn't it, as we develop new technologies and refine our techniques.
Right.
Who knows what we might find, perhaps even heavier elements with even more exotic properties.
Maybe we'll discover elements that challenge our very definition of what an element is.
Right.
Or elements with properties that seem like something straight out of science fiction.
The possibilities are truly mind-boggling. We might find elements with unexpected applications in medicine, energy production, or even space travel.
This deep dive has certainly opened my eyes to the vastness of the unknown
It is vast.
and the incredible dedication of scientists who are constantly pushing the boundaries of human knowledge.
It's a testament to our innate curiosity, our desire to understand the world around us, even at the most fundamental level. Mendelevium might be a fleeting, elusive element, but its story is a powerful reminder of the enduring power of scientific exploration.
Beautifully said.
Yeah.
So for our listeners, you continue to explore the world of science and technology. Remember Mendelevium, the element that exists at the edge of what we know, beckoning us to venture further into the unknown. Who knows what incredible discoveries await us just beyond the horizon?
It's an exciting time to be alive.
It is. Thanks for joining us on this deep dive into the fascinating world of Mendelevium.
It really makes you appreciate the power of basic research, doesn't it?
It does. We might not see immediate practical uses for something like Mendelevium,
Right.
but the knowledge gained from studying it could have ripple effects throughout science.
Absolutely. It's like laying the foundation for a skyscraper. You might not see the finished building right away, but without that strong base, it would never be able to reach such heights.
That's a great way to put it. And it's not just about potential future applications, is it?
No.
Studying Mendelevium also helps us to understand the limits of what's possible in the universe.
Exactly. Mendelevium is pushing the boundaries of the periodic table as we know it. It challenges our understanding of nuclear stability, the forces that hold atoms together, and even the fundamental nature of elements themselves.
It really makes you wonder what other secrets are hiding at the edges of the periodic table.
It does. There's so much more to explore.
What other elements might be out there waiting to be discovered?
It's an exciting thought, isn't it? As we develop new technologies and refine our techniques, who knows what we might find? Perhaps even heavier elements with even more exotic properties.
Maybe we'll discover elements that challenge our very definition of what an element is, or elements with properties that seem like something straight out of science fiction.
The possibilities are truly mind-boggling. We might find elements with unexpected applications in medicine, energy production, or even space travel.
It's incredible to think about all the possibilities.
It is.
This deep dive has certainly opened my eyes to the vastness of the unknown and the incredible dedication of scientists who are constantly pushing the boundaries of human knowledge.
It's a testament to our innate curiosity, our desire to understand the world around us, even at the most fundamental level. Mendelevium might be a fleeting, elusive element, but its story is a powerful reminder of the enduring power of scientific exploration.
Well said. And on that note, I think we've reached the end of our deep dive into Mendelevium. It's been a fascinating journey exploring this elusive element, and I hope our listeners have enjoyed it as much as we have.
I certainly enjoyed our conversation. It's always a pleasure to delve into these scientific mysteries.
To our listeners, if you enjoyed this episode, be sure to subscribe and check out our other deep dives on various fascinating topics. Until next time, keep exploring, keep questioning, and never stop learning.